Lesson 4, graphs of sinusoidal functions. So anytime you have something that's traveling in a circle, like a wheel or a tire, it will make a sinusoidal function. So we have the following word problem, and it represents the height, or the rotation of the highest Ferris wheel in the world, which is in China. So we're going to determine the following information from the graph. So we want to find the minimum value, and what does that represent? So our minimum value is right here. It's a little bit, it tells us right here, 0 and 2. So minimum is equal to 2. So if you're having trouble picturing this, we have a Ferris wheel. This is where my art degree really comes in handy. So we've got a Ferris wheel. If you're in Disneyland, there's a Mickey Mouse in the middle. And a sun. Anyways, what this 2 represents is the lowest point. So that means it's 2 meters above the ground, where the little cars go. 2 meters above the ground. So the lowest point is how high the Ferris wheel is off the ground. And when it says to explain something within context of the equation, I don't want to just hear that the minimum is 2 and that's the smallest point. It needs to actually make sense to the question. So it's how high the Ferris wheel is off the ground. It has to be specific to the question. So the maximum point would be right here on top of the Ferris wheel and at 160. And what that represents is how tall the Ferris wheel is. And that's how high the cart that you're traveling in gets when you're at the top. The range is 2 less than or equal to y less than or equal to 160. And if we wanted to figure out what the range is between those points, we would go 160 minus 2, which is 158. And if you look at our picture, between 2 and 158 is our range. That's the diameter of the Ferris wheel. The amplitude, so we probably will need our midline first. So to find our midline, we take our maximum plus our minimum and divide by 2, and you should get 81, which is right here. So our midline would be the center of our circle. This is our midline at 81. So the amplitude would be from here to here. So that's kind of the radius of the circle. So the amplitude would be 160 minus 81, which is 79. So it's the radius of the circle. And it's how high the car travels, either up or down from the center of the circle. If you want to write that, I don't. It'll take too long for me to write that. Alright, E, what is the period length and what does it represent? So to find our period length, we'd go from maximum to maximum. So our maximum here is at 15 to 45. We can also go from our start to our finish, but it's a little bit off the axis on the midline. Oops. So that one's not as easy to do. So we're going to go start to finish. So 45 minus 15 is equal to 30. And we want to go from those points just because they're given to us right on the graph. So 30 minutes is the time it takes for you to go around the entire Ferris wheel. Yes, I'm getting shorthanded now. So the time it takes you to get around the Ferris wheel. Next, how long does it take to get to the top of the Ferris wheel? So that would be half of a rotation. I don't know which way Ferris wheels go. So half of a rotation would be half the period length, which is 15 minutes. What is the diameter and the radius of the circle? So we already found the diameter to be 158 and the radius to be 79. We got that from the amplitude and the range. Okay, suppose lights are placed halfway on the Ferris wheel. Graph the movement of one light on the Ferris wheel. So, we're getting fancy here. Halfway on the Ferris wheel, we're adding some lights to make it more exciting. Aren't they beautiful? So, what we want to do is we've changed the radius of the circle, which is going to change a lot of things. So, if it's half of the circle, that means that the diameter is also half. So our new diameter is 79. So our new radius would be 39.5. Our midline would still be in the center here. So our amplitude will be the radius. So to find our new max and our new min, we're going to take our midline, which is 81, and then add the amplitude, which is our radius. So 81 plus 39.5 is our max, and 81 minus 39.5. And we can round that to 40. So this is roughly 121, and this one is 41, just with rounding. So when we graph this, our new maximum point, our period length will stay the same. It's still rotating the same speed. The only thing that changes is the maximum and the min. So our new maximum is 121 right here. Our new minimum is 41 right here. So our graph for this light would look, like this. And it still crosses the midline in the same spots. Those will overlap. Wow, that's awful. You get the picture. This should go down to here. So that would be the graph of the light. So it's just the same period length, different amplitude. That's all that changes. All right, sketching graphs. You have to be really careful when you're sketching graphs to find all the information from what you've been given. So sketch the graph of a function with the following characteristics. From 0 to 360, with a range of -5 to -9, and a period of 120, and a y-intercept of 2. So, because we have our range, our max is 9, and our minimum is -5. Our midline then would be at 9 minus 5 divided by 2, which is 4 over 2, which is 2. So we can just lightly draw this in on your graph to start with. Now we need to find our amplitude. So we take 9 minus 2, and you get 7. Or you take -5 minus 2, which is -7. So that works. Now we want to find our, we know our period length to be 120. So what we're going to do to help is we're going to split this into 4. So what this helps us do is that every quarter of 120 will be a point. So the first quarter will be at the midline, the second quarter will be at the max, the third quarter will be at the midline, and then the last quarter will be at the minimum. So we're going to find each of those points. So if you take 120 and divide it by 4, you get 30. So our first midline will be at 30 degrees. Just kidding, I have that backwards. You start at 0, and your first quarter will be at the maximum. Your second quarter will be at the minimum, midline. The third quarter will be at the min, and the last quarter will be, I don't know how to write this. So you should start mid, go to the max, mid, min, go to the middle again. So 0 starts here, which is 0 degrees, then it'll be 30 degrees, then it'll be 60 degrees, then it'll be 90 degrees, then it should be 120 degrees. So what's important to notice is that by the time you get to the end, it should be your period length, which is 120. So to label our graph, it's important to label using this just to make it easier on yourself. And we also need to draw the graph from 0 to 360. So 360 degrees has to fit on this graph. So I would try doing it every 2 to give yourself some space. If that doesn't work, or you have more space, you could try 3, 30, 60, 90, 120. So just label all of your degrees in, and yes, I want you to label them all in. So this one fits on our graph fairly well. So to graph this now, our 0 degrees is going to start on our midline, which is 2, which is our y-intercept, which fits. Then at 30 degrees, it's going to go to our maximum. Our maximum is 9. So at 30 degrees, it'll go to 9. At 60 degrees, it'll go back to our midline. At 90 degrees, it'll go to our minimum at -5. And at 120 degrees, it should go back to our midline. So you're just going to repeat that process, keep going. So 2, and then it'll go to your maximum. Another 2, and it's your midline. 2, and it's your bottom. 2, and it's your midline. So fill all of these points in. And you want to stop at 360 because that's what our domain says. Then you're going to just carefully draw in the curve. This is not easy on the iPad. I did my best. Not really, but there's your sine function. So it should look something like that. Alright, our last example, determine the range, equation of the midline, amplitude, and the period for each graph. So to find the range, we need our maximum and our minimum. So it's between 2 and -4. So our range is y such that, -4 is less than or equal to y, less than or equal to 2. Remember, 2 blanks, 1 for your small number, 1 for your big number. Y is an element of the real number. Now we're going to find our midline. So we're going to take 2 minus 4, divide by 2, which is -2/2, which is -1, which as you draw it in, it does look like it's in the middle. And our period length would be from where it starts and touches the midline till where it ends on the midline. So you go to the maximum, midline, minimum, midline. This is our ending point. And it looks like it crosses here at about 5. Or period, wrong one. Another way you can look is that halfway right here is exactly on 2.5. So 2.5 times 2 is 5. So this is measuring now in radians rather than in degrees. So you can graph in radians. knowing that one normal cycle would be 6.4 radians. Alright, now we're going to do example 2. So our maximum point is negative 0.5. Our minimum point is negative 1.5. So our range is y such that smallest number less than or equal to y, less than or equal to biggest number. So negative 1.5, negative 0.5. Y is an element of the real number set. Now we're going to find our amplitude, so we take negative 1.5 minus 0.5 divided by 2, which is equal to negative 2 over 2, which is negative 1, which is correct. And now our period length. So the easiest way to look at this one is we've got a minimum here and a minimum here. So that would be one full cycle. So it goes from 0 to 2. So our period length is 2. You can also go from here to your end here, and it is 2, but it's a little bit harder to see. So whenever you're doing your period length, either go from a max to a max, a min to a min, or from start to finish, whatever is easiest to see on your graph.